Our next problem says the image of triangle OXY under reflection in the origin is the triangle OX1Y1, where x1 has coordinates -3, -4 is the image of x, and y1 with coordinates 0, -5 is the image of y. Write down the coordinates of x and y. What kind of figure is this quadrilateral x, y, x1, y1? Give a reason for your answer. State with a reason whether this figure has lines of symmetry. Now, first of all, we take a graph sheet. We draw the x-axis and the y-axis. We mark the points x1 and y1. Now, draw triangle OX1, y1. Now, we want to reflect this in the origin. We will get the coordinate of x as 3, 4 and the coordinates of y as 0, 5. Now, we join the triangle OXY. Here we want to join XY, X1, Y1. When we join this, we observe that the opposite sides are equal and parallel. Also, the diagonals are equal, and we also see that each vertex angle is a right angle. So this figure is obviously a rectangle. Now in this question, we are also told to state with reason if this figure has any lines of symmetry. Now we've got this figure as a rectangle, and we know that a rectangle has two lines of symmetry, that is, the perpendicular bisectors of the opposite sides. So this figure will have two lines of symmetry. Now let's look at our next problem. The table below shows some points and their images under certain rigid transformation. Excluding the transformation, complete the following table by describing completely the transformation in each case. Now we are given the points and we are given their images. We want to find the transformation. Let's take the first point, that is 4, 2, and its image is -4, 2. Here we observe that the x coordinate sign has changed, whereas the y coordinate remains the same. So this reflection is obviously in the y-axis. Now let's take the second point. It's -2, 5, and the image is 2, -5. So here the sign of both the coordinates have changed. So this reflection is in the origin. Now take the third point. We have 3, -2, and the image is 3, 4. So the x coordinate is the same, but the y coordinates are different. And they are just not different in the sign, but even the numbers are different. So it is reflection in some line. Now which line could it be, y or the x? So let's see that. We take the difference of these 2 points, that will be 6 units. Now divide that by 2, that is 3 units. So each of these points should be at a distance of 3 units from the line. So we will get the required line as y is equal to 1. Now let's take the fourth point. It's 3, 7, and its image is 3, 1. Again over here, the x coordinate is the same, but the y coordinates are different. So we take the difference, that is 6, divide by 2, again 3. Now each point should be at a distance of 3 units from the axis of reflection. So the required line will be y is equal to 4. Now let's take the last point, minus 1, 2, and its image is minus 3, 2. We want to reflect this in some line. Now here the x coordinates are different, but the y coordinates are the same. So we take the difference between them and we will get reflection in the line x is equal to minus 2. Now in a question, we have use graph paper for this question. Plot A 3, 2 and B 5, 4 on the graph paper. Use 2 centimeter equals 1 unit on both the axes. Reflect A and B in the x-axis to A dash, B dash. Plot these on the same graph paper. Write down the geometrical name of the figure AB, B dash, A dash. Then the axis of symmetry of AB, B dash, A dash. Also the measure of the angle AB, B dash. The image A double dash of A when A is reflected in the origin. And the single transformation which maps A dash to A double dash. Now in this case, we will first take the graph sheet, draw the x-axis and the y-axis. Now we are given the coordinates of the point A and B. Let's mark them on the graph sheet. A with coordinates 3, 2 and B with coordinates 5, 4. Mark them. Now we reflect A and B in the x-axis. So the x coordinate will remain the same, whereas for the y coordinate the sign will change. So we will get A dash with coordinates 3, minus 2 and B dash with coordinates 5, minus 4. Now join A, B, B dash, A dash. When we look at this figure, it is an isosceles trapezium. Now in the question, we are asked to write down the name of this geometrical figure, that is isosceles trapezium. Now we want to know the axis of symmetry of this figure. Now we know that axis of symmetry for an isosceles trapezium is 1, that is the perpendicular bisector of the parallel sides. So in this case, the axis of symmetry will be the x-axis. Now we want to find the measure of angle AB, B dash. We measure that, we will get it as 45 degrees. Now in the fourth part, the image A double dash of A when reflected in the origin. Now reflect A in the origin, the coordinates sign will change. We get A double dash with coordinates as minus 3, minus 2. Now we also want to find out the single transformation that maps A dash to A double dash. That is A dash with coordinates 3, minus 2 is transformed to A double dash with coordinates minus 3, minus 2. So the reflection is obviously in the y-axis. Now let's move on to our next problem. Here, points 3, 0 and minus 1, 0 are invariant points under reflection in the line L1. Points 0, minus 3 and 0, 1 are invariant points in the line L2. Now we are asked to name or write down the equations for the lines L1 and L2. Write down the images of the points P and Q when reflected in the line L1 as P dash Q dash respectively. Also, write down the images of P and Q when reflected in the line L2 as P double dash and Q double dash respectively. State or describe a single transformation that maps P dash onto P double dash. Now in this also we will draw on the graph sheet. Now let's use a graph sheet for this. We mark the points 3, 0 and -1, 0. Here you will observe that the y-coordinate for both these points is 0. Now we want to see when are they invariant, that is on which line will they be invariant. Now these 2 points obviously lie on the x-axis, so they will be invariant under reflection in the x-axis. That is line L1 is the x-axis. Now let us take the other 2 points, mark them 0, -3 and 0, 1. Here the x-coordinate of both these points is 0. So these points are obviously on the y-axis. So they will be invariant on the y-axis, that is line L2 is the y-axis. Now in the next part we want to write down the equations of the lines L1 and L2. So the equation of the line L1 will be y is equal to 0 and the equation of the line L2 will be x is equal to 0. Now write down the images of the points P and Q when reflected in the line L1, that is nothing but the x-axis, as P dash and Q dash. So we will get P dash as 3, -4 and Q dash as -5, 2. Now in the next part, write down the images of the points P and Q when reflected in the line L2 as P double dash and Q double dash. Here the reflection will be in the y-axis, that is the x-coordinate will change. So we will get P double dash as -3, 4 and Q double dash as 5, -2. Now we want to write down a single transformation that maps P dash to P double dash. That is P dash has coordinates 3, -4 and P double dash has coordinates -3, 4. That is the sign of both the coordinates changes. So the reflection is obviously in the origin. Now let's move on to our next problem. A, B, C are the vertices of a triangle in the coordinate plane. Write down the coordinates of A1, the reflection of A in the x-axis, and A2, the reflection of A in the origin. Write down the coordinates of B1, the image of B when reflected in the y-axis. Name the 2 points which are invariant under reflection in the y-axis. Also, name the image of triangle ABC by reflection in the y-axis as triangle A3, B3, C3. Name the figure A, A3, C, C3. Now let's use the graph sheet for this. We draw the x-axis and the y-axis. Now we mark the point A with coordinates as 4, 6, B with coordinates 0, 8 and C with coordinates 0, -10. Now we are told that point A is reflected in the x-axis. So the coordinates of A1 will be 4, -6. Now also point A is reflected in the origin to get A2. So A2 will have coordinates as -4, -6. Now point B is reflected and we get the point B1. So we will have B with coordinates 0, 8 when reflected in the y-axis will give us B1 with coordinates as 0, 8. Now here you observe that the coordinates do not change because the x coordinate is 0 and this point is reflected in the y-axis. Such a point is called invariant point. Now the next part says, name 2 points which are invariant under reflection in the y-axis. So one point is obviously B with coordinates 0, 8 and the other point will be C with coordinates 0, -10. So we have these 2 points which are invariant under reflection in the y-axis. Now we want to draw the image of triangle ABC as triangle A3, B3, C3. In the reflection, when we take the reflection under y-axis, let's mark the point A3 that will have coordinates as -4, 6. Now you will observe that B, when it is reflected in the y-axis, the coordinates will not change, and same way for the point C, the coordinates will not change. So we have the triangle A3, B3, C3 the same as triangle A3, BC. So we have got the image of triangle ABC. Now let's join the points A, A3, C and C3. When we join this, the figure obtained is a kite. Now let's look at this topic from the board point of view. This topic carries 3 to 4 marks in the ICSE board examination. There is one question based on this topic, mostly in section B. Now where can you lose marks in this topic? Always read the question properly, that is, you're told to reflect in the x-axis or y-axis and do accordingly. Also, always draw a graph or a figure in your answer booklet. Now, let's take the board problems. We start with the March 2005 board question which says, use a graph paper for this question. Take 10 small divisions equals 1 unit on both the axes. P and Q have coordinates 0, 5 and -2, 4. P is invariant when reflected in an axis. Name the axis. Find the image of Q on reflection in the axis found in 1. Also, 0, K on reflection in the origin is invariant. Write the value of K. Write down the coordinates of the image of Q obtained by reflecting it in the origin, followed by the reflection in the x-axis. Now let's take a graph sheet. We draw the x-axis and the y-axis. Here we are told to take 10 small divisions as 1 unit. That is, we take 1 centimeter as 1 unit on the graph sheet. Now we want a point P which is invariant when reflected in an axis. Now here P is a point which is invariant when reflected in an axis. We want to find that axis. P has coordinates 0, 5 and it will be invariant when it is reflected in the y-axis. So the reflection should be in the line y-axis, that is x is equal to 0 will be that equation. Now for the second part, we want to find the image of Q when reflected in the axis found in 1. That is, we want to find image of Q when reflected in the y-axis. If you are reflecting in the y-axis, the x-coordinate sign will change. So we have Q with coordinates -2, 4. It's reflected in the y-axis. We get Q dash with coordinates as 2, 4. Now in the third part, 0, k on reflection in the origin is invariant. Invariant means the value remains unchanged. That is, we reflect 0, k in the origin and we again get the point 0, k. So we have 0, k is equal to 0, minus k. Because we are reflecting in the origin, so the sign of both the coordinates will change. But here we have 0, k is equal to 0, minus k. That is, k is equal to minus k. Take on one side, we have 2k is equal to 0. That is, k is equal to 0. So we've got the value of k as 0. Now in the next part, write down the coordinates of the image of Q obtained by reflecting it in the origin, followed by reflection in the x-axis. So we take this point Q with coordinates as -2, 4. Reflect this in the origin, we will get Q dash with coordinates as 2, -4. Now this point is reflected in the y-axis. We will get Q double dash with coordinates as 2, 4. Now let's take the March 2006 board question. Use graph paper for this question. The points A, B, C are the vertices of triangle ABC. Write down the coordinates of A dash, B dash, C dash. If triangle A dash, B dash, C dash is the image of triangle ABC when reflected in the origin. Now the second part in this says, write down the coordinates of A double dash, B double dash, C double dash. If triangle A double dash, B double dash, C double dash is the image of triangle ABC when reflected in the x-axis. Mention the special name of the quadrilateral BCC''B" and find its area. Now in this we are given the coordinates of 3 points A, B and C. Now we are told it is reflected in the origin to get A', B' and C'. Now take A with coordinates 2, 3, reflect in the origin, we will get A' with coordinates as -2, -3. Now B has coordinates 4, 5, reflect in the origin, B' will be -4, -5. And C has coordinates 7, 2, reflect in the origin, C' has coordinates -7, -2. Now we plot this on the graph sheet. First we draw the x-axis, y-axis, mark the points A, B and C. Then we mark the points A', B', C'. Now we will reflect it in the x-axis to get A', B', and C'. Now A has coordinates 2, 3, reflect in the x-axis. We have A'' with 2, -3. Now B has coordinates 4, 5, reflect in the x-axis. B'' will have coordinates as 4, -5. And C has coordinates 7, 2, reflect in the x-axis. C'' has coordinates 7, -2. We mark this also on the graph sheet. Now we are told to join B, C, C'', B''. Let's join this. Now the figure obtained is an isosceles trapezium. Now we are also told to find the area of this figure. Now we know that area of a trapezium is half sum of the parallel sides into distance between them. So we will get half into C, C'' plus B, B'' into the height, that is CD, which is equal to half into 4 plus 10 into 3. Simplify this, half into 14 into 3, that is 7 into 3, which is 21 square units. Now let's take the March 2008 board question. Use a graph paper for this question. Take 1 centimeter is equal to 1 unit on both the axes. Plot the points A, B, C and D. Draw the line of symmetry of triangle ABC. Name it L1. Point D is reflected about the line L1 to get the image E. Write the coordinates of the point E. Name the figure ABED and also draw all the lines of symmetry for the figure ABED. Now let's take the graph sheet, draw the x-axis and the y-axis. We will write the scale as 1 centimeter is equal to 1 unit on both the axes. Now we mark the points A, B and C. A has coordinates -2, 0, B has coordinates 4, 0 and C has coordinates 1, 4. Now we are told to draw the line of symmetry of this triangle ABC. Now if we look at triangle ABC, it is an isosceles triangle. We know that the line of symmetry of an isosceles triangle is the angular bisector of the vertex angle or the perpendicular bisector of the base. So we have line L1 as the line of symmetry for the triangle ABC. Now, point D is reflected about the line L1 to get the image as E. Now we mark the point D with coordinates -2, 4. Now we want to reflect D in the line L1. Now the line L1 is x is equal to 1. Now we want to reflect in this line. Now if you'll observe, the distance of the point D from this line is 3 units. So the distance of the point E from this line should be again 3 units, but on the opposite side. So we mark the point E with coordinates as 4, 4. Now join ABED. What does this figure look like? It is a rectangle because opposite sides are equal and each angle is 90 degrees. So we have ABED as a rectangle. Now we are told to draw all the lines of symmetry of this figure. We know in a rectangle there are 2 lines of symmetry, that is the perpendicular bisectors of the opposite sides. We already have one line marked, that is line L1. Then we mark L2 as the perpendicular bisector of the opposite sides. So we have got the 2 lines of symmetry as L1 and L2. Now let's look at the brain map of this topic. We now know what is reflection. We've also seen reflection in the x-axis, in the y-axis, and in the origin. Also, we have seen what do we mean by invariant points. Let's revise this at a glance. What is reflection? The reflection of a point P in a line M is a point P dash such that line M is the perpendicular bisector of the line segment P dash. Then we had seen reflection in the x-axis. If you have a point P with coordinates as x, y and we reflect that in the x-axis, we get a point P dash with coordinates as x, minus y. Reflection in the y-axis, P x, y when reflected in the y-axis will give us P double dash minus x, y. And reflection in the origin, P x, y when reflected in the origin gives us P triple dash with coordinates as minus x, minus y. Then we had seen invariant points. A point is called an invariant point if it remains unchanged under a transformation. Now, this topic which we just covered is quite a simple one, but it is scoring, so study well and score full marks in this topic.